All right, in this video, I want to talk about our other algebraic approach to solving systems of linear equations, and that's using what we call the elimination method. In the elimination method, we're going to start by multiplying one or both of the equations in our system by a non-zero constant number with the goal of making the numbers in front of one of our variables or the coefficients in front of one of our variables match or be the same number but opposite in sign, like -3 and +3. This first step is really like a prep step. After we've done that, we move on to the second step where we're going to add the equations together. If our prep step worked or if step one worked correctly, after we've completed step two where we add the equations together, that should eliminate one of the variables. The variables with the matching but opposite coefficient should disappear. We'll then have an equation with one variable left over. We're going to solve for that remaining variable in step three, just like the step three we had for our substitution method. And step four is also the same as what it was for our substitution method. Once we know the value from step three for either x or y or one of our variables, we're going to plug that value into one of the original equations to solve for the other variable, the one we don't know the value for yet. And so I want to go ahead and apply our elimination method to this example. We're going to solve this system. -3x minus y is equal to 4, and 3x plus 2y is also equal to 4. Remember, we saw this system before when we were working with our substitution method. We solved it, and we're going to solve it again using a different method, but we should get the exact same answer. Okay, so let's go ahead and jump right in. Like always, I like to label or number the equations in my system. So the first equation is -3x minus y is equal to 4, and the second equation is 3x plus 2y equals 4. And so our first step is to multiply one or both of our equations by a non-zero constant number so that the coefficients, which are just the numbers in front of our variables, end up being the same for one of the variables, but opposite in sign. And this first step is actually already done for us because we can see the numbers in front of the x variable in our two equations are both 3's. One is -3 and the other is +3. So step one was actually already done for us in this example, but in our next example, we'll have to take care of step one. We're actually ready to move on to step two. So now we're going to take equation one and add it to equation two. So -3x minus y equals 4 is going to get added with +3x plus 2y equals 4. And so when we add equations together, we have to add the respective left and right hand sides together and combine like terms as we do so. So -3x plus +3x gives us 0 x's. The x terms cancel out. That's the whole point of this elimination method, is it's going to cause one of our variables to disappear. So what else do we have on the left-hand side? We have -y plus 2y. Well, that'll add together to give us just a single y. And that's equal to the right-hand side summed together or added together. 4 plus 4 is equal to 8. And so it looks like while performing the second step of our elimination method, we just coincidentally also performed the third step. We solved our resulting equation for one of our variables. By doing this, we see y is equal to +8. So now we're ready to move all the way down to step 4. We can plug our known y value of +8 into one of our equations and solve for x. Let's just go ahead and use equation 2 for this. So equation 2 says 3 times our x value plus 2 times our now known y value of 8 is going to result in 4. Well, that also says 3x plus 16 is equal to 4. Or if we subtract 16 from each side, 3x will be equal to -12. How do we get x by itself? Well, we divide both sides by 3, and we see that x is equal to -12 divided by 3, which simplifies to -4. So our point of intersection between these two lines, or the solution to our system of linear equations, is the point -4, 8. Remember, we solved this system earlier using our substitution method. We solved it just now again using the elimination method. And if you look at your answer, what you got the first time, it was also -4, 8. So it doesn't matter which method we use, they're going to result in the same answers. All right, let's go ahead and look at another example of solving a system of linear equations using our elimination method. This time, the system we're interested in solving has a first equation of 5x plus 2y is equal to -3. And the second equation in our system says 2x plus 5y is equal to +3. So this time that first step isn't done for us, so we got to start there. We're going to multiply one or both of our equations by some non-zero constants so the numbers in front of x or y become the same but opposite in sign. And so it looks like it doesn't matter if we do this for x or y because the numbers involved are the same for each. So let's go ahead and focus on x's. And so what we want to do is make the numbers in front of x in both of our equations become the same, but opposite in sign. So what we have to do is look at the coefficients in front of x and find the least common multiple of those coefficients. And that'll often just be the product of the coefficients. So another way to say that is, what is the least common multiple between 2 and 5? Or what number is divisible by both 2 and 5? And that is 10, which also just happens to be the product of 2 and 5. So we're going to multiply both of these equations by whatever number is necessary, so the numbers in front of x turn into 10 and negative 10 in our equations. But if we have to multiply the x term by some number, we have to multiply the y terms and the constant terms by that number as well. So we have to be careful. So let's go ahead and take equation 1 and multiply it by 2, and then that'll turn that into a 10x and also change these other numbers. And then we need the x term in the second equation to become a negative 10, so we'll have to multiply it by negative 5. So what we're really going to be looking at here is 2 times our first equation minus 5 times our second equation. Okay, so our first equation multiplied by 2 will become 10x plus 4y equals negative 6. I multiplied 5x by 2 to get 10x, 2y by 2 to get 4y, and negative 3 by 2 to get negative 6. I have to also look at negative 5 times our second equation. So if I multiply 2x by negative 5, we'll get negative 10x. Now the coefficients in front of x are the same but opposite. That's great. We have to multiply the rest of our second equation by that factor of negative 5 as well. 5y times negative 5 will give us negative 25y, and 3 times negative 5 will give us negative 15. And so now we finished our first step. We multiplied our equations so that the numbers in front of x are the same but opposite in sign. And now we're ready to add our two equations together, or add these new versions of our two equations together. And that will eliminate the variable of x, leaving us just an equation involving y. So if we add the x terms together, they just cancel out. If we combine the y terms together, 4 plus negative 25y gives us negative 21y. And that's equal to the sum of negative 6 and 15, which is negative 21. So now we can divide both sides by y and see that y must be equal to positive 1. So after we add the equations together, we got this really nice equation that only involved one of our variables. We solved for that variable and we got y equals 1. Now we're ready to finish this example off, finish our elimination method by taking our y value of 1, plugging it into one of our earlier equations and solving for x. It doesn't matter if we use equation 1 or equation 2 to find x. Let's go ahead and use equation 2 though. So equation 2 says 2 times our x value plus 5 times our y value, which we now know is 1, has to be equal to 3. So that also cleans up to say 2x plus 5 is equal to 3. We can subtract 5 from each side. That then says 2x is equal to 3 minus 5, which is negative 2. Divide both sides by 2, and we get that x is equal to negative 1. So what is our solution written as a nice ordered pair? Our x coordinate is negative 1, and our y coordinate is positive 1. So now we've seen another example solved using the elimination method. The solution to this linear system is negative 1, 1.